I'll find an employee, a colleague, who might say something like, why are we licensing software to other companies, our competitors, when we should be keeping that in-house, creating some competitive differentiation? The answer to that question is about ensuring customer success. Of course, competition is very important when that makes sense, and we'll be aggressively competitive when we need to be. But sometimes you have to cooperate with other software vendors in order to ensure the success of your customers.
You're listening to another episode of the Next Generation Design Podcast. I'm your host, Greg Arnott. On today's episode, I'm joined by John Rimmer, Product Management Specialist at Siemens Digital Industry Software, and Graham McBean, Director of OpenTools. Before we begin, let's meet our guests. Gentlemen, welcome to the show.
Thanks for having us, Greg.
Thanks, Greg.
John, I'd like to start with you. Can you elaborate a bit more on your role here at Siemens Digital Industry Software?
I work in the product engineering software department in Digital Industries Software. Now, for many years, I had a role in product marketing and management, responsible to support the licensing of our software technologies to other software vendors under an open business model. And this is why this topic of software vendor openness is very close to my heart. But more recently, I've moved into a new role. I'm supporting the product management team in working with our inbound software technology partners.
And Graham?
I manage the OpenTools division, which is part of the PES software within SW. What that includes is the open components that we use within our own products and that we sell externally. And there's a long list of different components that we produce. So it's an R&D organization.
Thank you both. Now, let's get right into it. John, we want to focus specifically on the topic of openness today. Can you explain what that concept means in the context of software?
I think the first point to make is that software vendor openness has many different aspects. And in the broadest of terms, an open software vendor like Siemens Digital Industries Software will be looking to address three broad categories. So firstly, an open approach to data. So this is all about enabling our customers to move 3D product and related data from system A to system B as efficiently as possible. Secondly, open software applications. So giving our customers the capability to extend and adapt our software to meet their specific business needs in certain situations. Thirdly, an open approach to community, an open approach to a network of partners that can support our customers through their expertise or location in software implementation, integration, training, sales, services, and so on. We've got a very expansive partner program and network. But secondly, customer communities, being open to supporting end users in coming together to discuss their challenges, getting our software vendors, our software representatives involved in helping them to solve their problems. And we do this through, for example, the NX community. And then also communities that are aimed at driving product development, or support for standards. So we might come on to talk about some of these topics like the JT Open program. And then last but not least, there are actually even communities where software vendors who compete come together with their manufacturing customers and other service providers to talk about the whole concept of openness and what vendors need to do in order to address the problems that customers are identifying in connection with this openness topic.
And is there anything special a vendor needs to do to succeed in these areas?
They really need to nurture an internal culture of openness throughout the organization. Call me biased, but I think that Digital Industries Software has among the best, if not the best, reputation for openness across software vendors. But that said, even time to time, I'll find an employee, a colleague, who might say something like, why are we licensing software to other companies, our competitors, when we should be keeping that in-house, creating some competitive differentiation. So the message isn't always getting across. The answer to that question, briefly, is it's about ensuring customer success. Of course, competition is very important when that makes sense, and we'll be aggressively competitive when we need to be. But sometimes you have to cooperate with other software vendors in order to ensure the success of your customers. So we have this concept of co-opetition that's important to our industry.
That's great, John. Thank you. Can you tell me why software openness is important to our customers?
In a nutshell, it's always been crucial for cost reduction and improving time to market. So let's think about this trend for end-to-end digitalization, and we'll take the large scale view. So big enterprise, expansive supply chain, and there are going to be all sorts of different software applications in play across all the domains that are involved in the evolution of that product, from requirements definition right through to manufacturing. And those applications, they're going to be coming from different software vendors. They may be applications that different companies have developed in-house to address their specific business needs. There'll even be the same software application running in different versions at different sites. So it becomes quite a complex network of different software applications at play.
And what about in regard to digital industries in particular?
Digital industry software is unique in that it will actually supply all the software and services a company needs for that full end-to-end digitalization process. But in practice, of course, users out there aren't relying on a single supplier, not least of all because they're going through mergers and acquisitions, and every time they do that, a whole new set of software applications come into play, or they're selecting different providers across their supply chain, again bringing in new software applications. So the key challenge, I think, for customers is to ensure that data is able to move across these applications as efficiently as possible. So that means without losing information, without 3D data or related data being corrupted because of errors in translation, and so on. And so an estimate I came across last year was that the cost to some of the larger enterprises through trying to integrate all of these heterogeneous software applications can run into millions or indeed tens of millions of dollars every year. So this is why an open approach from software vendors is so important in addressing that customer need for data interoperability. And I think this is one of the key aspects of software openness and why it's important to our customers.
John, to get some more background on Siemens' commitment to openness, can you tell us about the Code of PLM Openness?
This is an initiative that was set up maybe 15 years ago. It's under the auspices of a German organization called ProCep IVIP. They provide consultancy and services for industrial software users and software vendors. And the initiative they set up was to get, it was at the request of customers, and initially this was the large automotive OEMs in Germany. So companies like BMW, Daimler, VW, and they wanted to get together with some of the key software vendors and some service providers to discuss under one roof what openness means and to identify the various categories of openness and which criteria software vendors would need to satisfy in order to meet customer requirements. Siemens Digital Industry Software was one of the founding partners, alongside other software vendors like PTC and Dassault and Autodesk, all members, and then various software service providers like T-Systems, for example. And so over the past 14, 15 years, this group has been a bit more forensic in its analysis of what the various characteristics of openness are. If you look at the CPO, the Code of PLM Openness documentation, it's identifying 7 different areas, and for each area it comes up with criteria which software vendors should observe if they're going to claim to be open. Now that initiative goes has gone further. So it developed a certification for openness. It ran a pilot about 4 or 5 years ago, and you're pleased to say that Digital Industry Software, specifically product engineering software, so the NX organization participated in this pilot, and we passed with flying colors. Now, on the back of that pilot, work is now going on with the CPO initiative to actually develop a more robust certification based on the findings from that pilot scheme. So it's a very interesting initiative, as I say, because it's bringing together software vendors and manufacturing companies in the same room to talk about the openness topic, and that's a really good thing, I think. So there's work continuing with that initiative.
That all sounds very exciting. You specifically mentioned NX. How does NX software embrace openness to support customer access?
So one aspect of openness is support for customers' choice of IT infrastructure. Okay, so an open software vendor will recognize that customers are making big investments in various hardware operating systems. So this is another aspect of openness that we need to think about. And if you look at the deployment strategy for NXX, you'll see we're aligned with that approach, giving customers choice. So if users want to run NX on a desktop on premise, they can do so. If they want to run an installation of NX that's managed from the cloud, that's fine too. So they can create this kind of hybrid model like Microsoft Office 365. But if they even want to go ahead and stream NX through a browser, that's something we'll support too. So we're aligned with that topic of infrastructure support in terms of providing a capability to extend or adapt software. Then we offer NX Open. Okay, so this is equipping customers and indeed partners with programming tools, APIs for adapting NX to meet specific business needs. So this could be increasing productivity by developing automation tools for repetitive tasks or complex tasks, or it could be modifications to the user interface to support business or industry specific workflows, for example. So that's software extensibility supported by NX Open.
And in terms of data interoperability?
A few things here. So it's worth noting that users of NX can actually read in parts and modify them, parts that were created in earlier versions of NX. And I think this goes way back to the mid 80s with version 1 of Unigraphics. And this compatibility across software versions is really important because users have legacy data. But as I said earlier, there are also people at different sites and different companies using different versions of the software. So that compatibility across versions is also important. Also, in terms of interoperability, NX does a lot of work supporting various standard data formats. So these are internationally recognized standards that customers can use to reliably move data across applications. So in terms of NX areas like model-based definition, for example, there's support for STEP, file formats, JT, in manufacturing, 3MF. I mean, there's a very expansive list of standards that we're supporting. But our contribution isn't just about making support for that standard available in an application for import export. It's also about contributing to the evolution of that standard. So we get involved with the international committees that are driving the evolution of the standards so that we can ensure that standard is going to be fit for purpose for our customer base. So that kind of ties in with the topic of supporting open communities.
Does openness help with the concepts of a digital thread or the digital twin?
I view a digital thread as a subset of the end-to-end digitalization process. So all the remarks I've made are kind of true for end-to-end digitalization, but they're also inherited by digital threads. So there will be lots of digital threads where NX software is at play. So a digital thread is talking about the different solutions that will be at play to move a product through some part of the digitalization process and ensure that all the relevant stakeholders have access to what they need, whether they're designers, engineers, C-suite reviewers, sales, marketing, procurement, and so on. And so there are digital threads that we've identified. They're very useful for our customers because they map out the solution set they need. And NX will be playing its part in many of those digital threads. And the fact that we support openness on these different levels means that our software is fitting nicely into that digital thread.
Graham, please tell us more about the portfolio that your team at OpenTools develops.
OpenTools is a group that produces software components. That's products which have an API rather than a UI, and those products are embedded inside applications, inside the customer's applications. So we've got a number of different products. The most well-known, I guess, would be Parasolid, which is a geometric modeling kernel. Dcubed, which does geometric constraints, which maybe for 2D, you would see those in the 2D Sketcher. In 3D, you would see these in assembly positioning, perhaps. Next, we have Kineo, who do path planning and motion simulation. So big applications of that would maybe be in robotics and planning the motion for robotics, or for assembly, disassembly scenarios in automotive and aerospace. Next, we would have GeoLus. GeoLus is a search engine, just like Google's a search engine, except GeoLus searches on geometric shape rather than on textual attributes. And finally, JT Open. JT is a file format which we export and primarily used for visualization and collaboration, but we also have a community of customers built around that.
Can you tell me, where exactly are these products used, and are they available to the public?
All these products are used throughout Siemens applications. It's not just NX and Solid Edge, it's the manufacturing, it's simulation, it's the electronic divisions and products. So they're used across all of Siemens. And we not only get the standard reuse benefits from using the common software, it greatly enhances the quality of our products to use these common products. And we also benefit from better compatibility between our products. They work better together because they're using these common components better than they could do if they were not. But in addition to Siemens' widespread use of all these components, we sell them externally, and we sell them to anyone who would like to buy them, including our biggest competitors. And we sell it under a level playing field policy. That's what we call it. What that really means is everybody gets the same software at the same time. So it's level playing field in terms of developing their applications on top of our components. And this is really unique in the industry. There isn't other companies who both develop the components and use them everywhere, as well as sell them to outside their own organization. There are companies that develop components and sell them, but then they're not used internally, and vice versa. There's people who will develop components, but then they'll not make them available externally. So this is unique to Siemens. It's highly successful.
Are you able to give us any examples of OpenTool customers?
We have more than 400 different customers, licensees, producing thousands of different applications that embed our products. The big names you may have heard of are SolidWorks, Ansys, PTC, Onshape, Autodesk. All use multiple of our components, in fact, in order to develop their applications. So this has been successful, and in terms of end users, we estimate that every day there's more than 10 million engineers sitting down using applications that are powered by our Siemens components.
That's very impressive, both in terms of the number of licensees and the number of end users using Siemens technology. I'd like to hear more now about some of these components, especially Parasolid and JT. Can you start by telling me what role Parasolid plays in Siemens' openness strategy?
Parasolid is the biggest of these components and probably the oldest, the first to come along. In fact, the openness strategy really started to develop and evolve with Parasolid. Parasolid was first released in 1989, and soon after that, it was decided to continue to sell it externally as well as use it internally. It's a geometric modeling component. So what that means is it's the geometry engine that sits in the middle of any application, primarily the CAD applications, that defines the shape that you're modeling through the creation of the shapes, the editing of the shapes, and then asking questions of the shapes, the inquiries and the analysis of those in order to drive our manufacturing and simulation software. There's over 1,000 different APIs there, and it gives a huge range of flexibility. The applications that's included in is not just the range that are included in Siemens. There's a broad range of applications that we sell to externally, which cover other industries. So, for example, Parasolid's one of the biggest industries has been the AEC market for 25 years. And that's not an area where we have a huge presence within Siemens, but because Parasolid has been supporting the AEC industry with the types of edits and the types of construction techniques they need and the volumes of data that they need. That has provided additional capabilities to Parasolid that all the Parasolid adopters, both internal and external, can benefit from. In the very early days of Parasolid, we published the XT file format, which is the representation of the BREP format. And that BREP format, how you represent a 3D solid in the computer, that originated here in Cambridge, out of Cambridge University. In fact, exactly 50 years ago, those papers were first published and Shape Data was formed. And we're still here and still growing. So this format of XT, where the benefit comes is that anybody who is using Parasolid can exchange those XT files between their applications and any other applications that use Parasolid seamlessly without any translation. So you just pick up the XT file and you drop it in. You drop it from NX, you drop it into SolidWorks. From SolidWorks, you drop it into ANSYS. It's zero translation, 100% reliable. A lot of people license Parasolid, even if they're not going to license Parasolid for modeling, they'll license it for that interoperability to help them move data between the thousands of applications that use Parasolid out in the field. And that interoperability combined with the improved and stability, performance, robustness from the heavy casework that Parasolid does across that industry, that's where the big benefits comes in those industries.
Wow. I can really see the appeal of the XT file format, the way it gives zero translation interoperability over a vast swathe of CAD applications. And what role does JT play in our openness strategy?
Well, JT is key to our openness strategy these days. JT originated as a visualization format. Now it's become much more. We use visualization and collaboration principally. What it is a data format that holds a number of different types of data, containers of data, if you like. So there are 3 different facet formats within JT. Very loose one, perhaps for visualization, if you're looking to see something at a high level, and then moving a mid one, and then a more detailed one. Then Parasolid XT is one of the components within a JT file. Then you've got product manufacturing information, metadata, and a variety of other data, all contained within different containers within that JT file. You don't have to have everything there. What you do is you fill in the pieces that are most use to your company.
Can you expand on that a bit more for our audience?
This started off just with visualization. It's moved into interoperability for the similar reasons for Parasol. If multiple people have JT files, they can be transferred seamlessly between different organizations. Now, a number of years ago, 10 plus years ago, we were approached by a group of our largest customers, people like GM, Daimler, Volvo, etc. And they asked that we set up a community around JT in order to drive the future content of JT file format and to proliferate the use of JT across the industry, because they'd see benefits in seeing it used as widely as possible. So we did that. It's called the JT Open Program, and it's been a tremendous success. It's still going very strongly today, and all these companies, over 100 companies, get together several times a year and talk about what they've been doing with the JT format and how they might exchange it better, and how they might increase its usage. And that's very valuable. Now, there's been a number of directions they've pushed it, and a number of directions that we've had successes there. So there's a free viewer there now available to anybody to look at the JT file and see what's there. We published the JT file format in exactly the same way as we published the Parasol format. And then we went a step further and we got that file format recognized within the ISO community. So JT is now an ISO standard. And that really helps the enterprise customers have extra confidence in the use of JT, not so much for using it on a day-to-day basis where they're already very happy with it, but for storing data in it for a long-term archival process, or for the length of time for a car program, for example. They really need to have confidence that it's not going to just change or just go away.
And this has been a great success, I take it.
With, as I said, over 100 different corporate vendors and a large number of vendor members who sell into the community, who add JT support into their applications, which we aid by giving people another component to help them read and write the JT file. But the numbers here are amazing in terms of the number of files being produced by our biggest customers. You know, we had a look recently and found that we stopped after counting just 8 of our corporate customers, and they already had over 100 million JT files out there. So the numbers are spectacular, and they're being produced at an amazing rate.
Thank you for telling us more about Parasolid and JT. It sounds like they've been quite the success. Is there a way for people to learn more about PLM components?
First port of call is probably our website, and so siemens.com/PLM components. One of the easiest ways to get familiar with the components in detail is to complete one of our trial requests. So there are various forms where you can submit information. That'll put you in touch with an account manager. They'll provide you with information about the products, and then if it makes sense for you to have a no-cost 60-day evaluation of the software, they'll make that happen. So I'd recommend that as the best way to learn more about the products.
Great, and we'll make sure to link to that in our show notes for our listeners. John, before we leave today, I'd love to know, what is your future vision for the role of Siemens in software openness?
Firstly, we certainly want to expand this ecosystem that Graham's talked about for Parasolid and JT. So as he said, we're seeing tremendous engagement with those standard formats, with double-digit millions of Parasolid users, 100 million JT files. I think 7 of the top 10 automotive OEMs were using JT at some place in their supply chain. So really well-established footprint, but one we're looking to grow.
Well, I certainly look forward to all that coming together. Is there anything else you'd like to leave our listeners with before we say goodbye?
Just to reinforce a comment that Graham made about the adoption of Parasolid across, the Siemens Xcelerator platform. So all the applications through design, simulation, manufacturing based on this Parasolid format. And I think, Graham did raise this point, but I just wanted to hammer it home, and it's the fact that if we get if you have a user of NX out there, they can have the confidence that their data can move across all of the Siemens Xcelerator platform without any loss of fidelity of the Parasolid data model. And that's something our competitors can't claim, right? Because we have significant competitors out there that are using different geometric modeling kernels. So they'll be using their own proprietary kernel for perhaps their high-end solution, but then they'll be using Parasolid in many cases for their mainstream solutions. So they don't have this compatibility across their applications in the same way that we do. So this is, I think, another big advantage for the NX customer community, because they know they've got that seamless data connection going across our portfolio.
Excellent. John, Graham, thank you both so much for your time today. It's been a pleasure speaking with you both and learning more about software openness and the software tools that Siemens has available. Thanks again to John and Graham. We look forward to seeing you again soon. Thanks also to our listeners for tuning in to today's episode. Join us again next time for more discussions about the latest in design innovation and software applications. If you haven't already, please consider subscribing to our podcast on your favorite platform. And if you're enjoying the content, well, please leave us a review. I'm your host, Greg Arnott, and this has been the Next Generation Design Podcast.